I'm factoring as I go. So I have x minus 4, x plus 3, 8x squared, times 8x squared, x minus, actually I went to 8 there, I'm sorry, 2x squared, and I have what, a 4x minus 1, and then up here I have x squared, and then x plus 3, and then do the same thing with the last chunk, and it's just an x plus 2, and a 4x minus 1. Do you guys run into Hannah at all on Thursday and start going dinner? You should have. It's funny. And then you start going through. X squared, x squared. Then we have an 8, so this becomes a 4. That goes. So your numerator is x minus 4, x plus 2. And your denominator is 4x squared. Okay? Don't ever have to multiply out numerators at all. Actually, probably just have to multiply anything. If you're left with just terms like that, just leave it. Okay. Yes, sir. I was going to get the other one real quick, and I'll go back to that. What was it, 47 or 40? 49? As you're going down, as you're going through it, just factor it as you're writing it down. So you have x, what is that, x 12 to 20 would be what? 10 and 2? 4x squared minus 9 is the difference of squares. 2x squared, I'm sorry, 2x plus 3, 2x minus 3. Take out the 3x squared, and we have a 2x minus 3. Take out the x squared, oops, and then we have x plus 10, and then a 2x plus 3 over 1. And just start going. A whole lot of then. Alright. Honestly, the biggest thing here is just factor, get your pairs and simplify them out. Pairs of ones. Okay. And then the last one was 25 years, saying? That's not roll. Excuse me. Uh, 15 times 18, let's see, 225 and 45 is what, 260? Does that sound right? Yeah. 260 to get you to negative 8. So it's negative 260 to negative 8. So if you start breaking it apart, if that's 26 and 10, that's not going to work. So you're going to look for something closer between the two. 270. So 270? Yeah. Okay, I was close. So I know that 270. So I look for something that's closer. 12 maybe? 12, I don't know. I'd have to use P. No. Is it 15? Maybe. I don't know. If I only had a calculator. Sometimes. So that doesn't work. So I'd be looking. Come on. So here's my list, 27, 10. $15 and $18, and that's it. So that's not going to do anything in the numerator. denominator, the only thing you can do is take out a -2. You get 10x squared, 7x, and a 6. I don't think you can factor it any further. Did it do the quadratic on that one? Because that's now you get 60 to get you to 60. Oh, sorry, those should be negatives. Sorry, there should be negatives here. -60 to get you to 7 would have been. Yeah, -12 and 5, but then they still get the factor of the numerator, so might just been one. Yeah, you just get rid of it. Yeah, there's nothing you can do. All right. So then on Friday, I guess the audio still cuts out. So I apologize for that, but not a lot I can do. Yeah. I guess it worked for a little bit, but let's take a look real quick. Honestly, most of the stuff that you should have been doing, it should not have been all that difficult to get through. It is pretty straightforward stuff. The only thing that you're worried about now is that when you are adding and subtracting, you have to have common denominators. Okay. So in order to add or subtract anything, you have to have the same denominator. Think of it as when you had stuff like this, the 3x is the common, so you can just put the tops together. So what's 4 plus 5? 9. So your answer for something like that would have been 9 over 3x, but now what can simplify? The 3, yeah, so you get 3 over x because these guys can simplify out. Okay. Things like that, all right? The only difference was when you started multiplying things together to figure out your common denominators, I always like to go back to the idea of just some real simple fractions. To get a simple fraction here, what's the least common denominator that they both have in common? 6, right? So in order to do that, what I would do is, I know that I have to have a 3 times 2 in the denominator. Okay, that's how I get this 6. This fraction has a 3, it needs a 2. So that's why we multiply the top by 2. The other one needs the 3. And that's where you get 7/6 from. Okay? That's how that works. It doesn't change a whole heck of a lot once you start putting in all of your variables and stuff to it either. It's just factor, see what they have in common, and put it together. Okay? So when you, hopefully we're kind of going through this. I mean, obviously these are common, so that's easy, as you would have been 2x plus 7 over the x plus 5. Remember, when you're combining terms like that and you have that as your final solution, you cannot simplify anything over the addition. You are done. Okay? You are done. Bless you. When things get going to the non-common denominators, that's when you have to factor stuff first to figure out what they have in common. So when you got to one like this, you had figure out the GCF. This would have been a 4x here, and this would have been an x minus 3. And then here it's a 6x squared. Okay? Figure out the least common denominator. It's kind of when you start putting it all together. The easiest thing to do is that I know that I have to have an x minus 3. X squared and an x, what's the smallest amount they both have to have in common? It has to be the x squared. You're going into everything. And then what's the smallest number that both 6 and 4 go into? They go into, so the factors are going out. 12. Perfect. That would be the common denominator. So then you just ask yourself, what does each fraction need? Well, the fraction on the left has an x squared, so it needs the x minus 3. It has a 6, so it just needs to be multiplied by 2. So the left side, excuse me, the left side here would be 5 times 2, x minus 3. And then this one has the 4x and then x minus 3, so it needs an x. And what do you multiply 4 by to turn it into a 12? 3. So it needs another 3 and x, and then multiply the x. Yes, ma'am?
Where did you get the
Ah, 6 times what is 12? That's where I got it from. 4 times what is 12? 3. That's where I get the 3 from on the other side. Okay. We'll get more. We'll get more. All right. Put it all together, you wind up with 10 times the x minus 3, and then plus a 3x squared. This one, in these numerators, you want to clean them out, so you get 3x squared plus a 10x minus a 30 all over the 12x squared x minus 3. You don't have to multiply out the denominators, but you want to multiply, whenever you're doing the fraction stuff and you're adding and subtracting, you do always distribute and combine like terms in that case. Right. That's what that would look like. What? Yeah, common denominators, just like you would with any other normal fraction. Same basic thing, it's just with variables. Okay. All right. So it just takes a little getting used to. Go back to something easier. What do these guys have in common already? They have an x in common, right? Okay. What's the next number that both 3 and 5 go into? 15. So the common denominator has to be 15x. All right. Fraction on the left has a 5x. What does it need to be multiplied to turn it into a 15x? 3. So it just needs to be multiplied by 3. So it's 7 times 3. And the other one's 8 times 5. Yes. The math checks out. So you get 21 and 40 is what, 61, I believe? Yeah. So this is where you get 61 over 15 x and you're done. Okay. That's where all that stuff was coming from. And then as things get larger, you still are going to do the factoring before you do anything. Okay? So when you have larger trinomials and things that are factorable, as you're writing them down, factor it. Okay? So as I write this down, I have an x plus 1, x plus 2, and an x plus 2. Here would be 2 over x plus 2, x minus 2. These are actually even easier. What do they both have in common? Okay, so they have a set of x plus 2's in common. That's already taken care of. What's left? Yep. So I have an x plus 2, x minus 2 then to write out. Okay. Fraction on the left has 2 of the x plus 2's. What else does it need? Yes, sir. What do they have in common? They have one of them in common, and then what else is left? Okay. So this one needs an x plus 2. And then the other one has an x plus 2, x minus 2. It needs an x plus 2. Okay. Yes, ma'am. Did I say my? Yeah, you're right, sir. Thank you. I didn't even catch that. Sorry, guys. I meant to put the x minus 2 here. The x plus 1 already had 2 of the x plus 2's. It needed the x minus 2. That's what happens when I take a Friday off. I don't say day of math.
So basically, you just like give all this stuff.
What is that? I teach summer school. No. It's like 4 weeks. Then you FOIL out the numerator. So we get x squared minus 2x plus 1, so it would be minus x, minus 2, minus 2x, minus 4. Combine all that, you get x squared minus 3x minus 6 all over and you do not have to multiply out your denominators here. Okay? Not sure exactly where. Again, by going back and forth between something that was a little bit more difficult to something that's a little bit easier, you'll start to see how this kind of pans itself out. This one's really quick. Do they have anything in common?
Or no, they don't.
They don't have anything in common. These are terms, okay? They're not monomials, all right? So your denominator is going to be x minus 4, x plus 3. Fraction on the left needs x plus 3. Fraction on the right needs x minus 4. Okay? Always simplify your numerators. Don't multiply out the denominators. So you have x squared plus 3x minus 6x plus 24. So my numerator becomes x squared minus 3x plus 24 all over x minus 4, x plus 3. What times what's positive 24 to get you to negative 3? Did you guys get to the ambulance? It did. It just didn't work. So the ambulance. The ambulance is pretty funny. What's that? My son fell off the playground set at Jefferson when he was there, and I had to ride him in the ambulance to the hospital.
Oh, is he okay?
Yeah, he's fine. That explains a lot. That also explains a lot. Anyway, back on this one. So, same basic idea. It just looks awful. Okay? It looks awful. Now, when you get complex fractions, you get complex stuff like this. What you want to do is you really need to work piece by piece. If you look at the top numerator, there's nothing I can do with it. Okay? It's just 2 over x plus 2. The bottom part, it's being divided by a whole bunch of junk. That junk needs to get combined together because of the addition. All right? So what I do is I get the common denominator for this piece first before I do anything. So it's going to be x times the x plus 2. All right? Fraction on the left needs the x. Just needs the x. Okay? The fraction on the right needs the x plus 2. And again, I'm only going to simplify up that numerator. When I combine my like terms of that one, I'm going to get 3x plus 4. This piece here just goes right on over. Now, we think of it as, no, we can't yet. Think of this as fraction divided by fraction. It's just written vertically. When we divide by fractions, we're multiplying by their reciprocal. So what happens is you're going to, why does it show up there? You wind up with your 2 over the x plus 2 times x plus 2 over 3x plus 4. All right? I'm multiplying by that bottom's reciprocal, because that's the division stuff we did last week. And now you have a whole bunch of no. Well, just one. And that's what that would look like. Beautiful. All right. It's not that it's any more difficult, it just takes an extra minute or two to do the work, especially since there's so many little pieces that are happening. Okay, another one of those. Again, same basic idea. I set one up here that had a little bit less work involved to it than the other. This one, you have to get common denominators for both the top and the bottom numerators, or top and bottom for both of them. Because this is over 1, this is over 1. But as you go through it, it's real quick, okay? So you wind up with x plus 20. And this one becomes 8x plus 1 over x. Right? Fraction divided by fraction means I'm multiplying by the reciprocal. So you wind up with x plus 20 over 5 times x over 8x plus 1. And this is where you get your oh, and then multiply out your numerator. X squared plus 20x.
Monday morning.
Excuse me. Okay, I have one more of those. That's just the way it scanned it. All right, let's try that one. One of the things I would do as you're writing it down, you'll notice that the main denominator fraction, the 2 over the x squared plus 10x plus 9, that 2 already has a common denominator, because it's got that whole trinomial underneath it. So in an instance like this, I would be writing this down, I would get my common denominator stuff from the top part, but I know that the bottom part just needs to get factored and flipped as I'm going through it. Yes. Yep. Remember how the other ones had this as like 2 separate fractions? This one just doesn't. So I'd only have to worry about my common denominator up here, which would be 5 times the x plus 9. And this one's pretty quick, where you get the fraction on the left needs the 5, the one on the right needs the x plus 9. So I get x plus 14 over 5x plus 9. Factoring x squared plus 10x plus 9 is pretty easy. Plus 9 plus 1. So now I just have to say it and flip. So is it x plus 14? What's 5 times 2? 10. And then FOIL our numerator. So we get what? X squared, 15x, and a 14. And you're done. High foil on top again, remember always foil, always multiply out, combine like terms for here. And that's what that looks like. Excuse me. So in this one, again, as you're starting to go through, you want to factor your denominators to get your common denominator. All right. As you're writing this down, I would have written it down as 4 over x plus 5, x minus 5. That way you're a step ahead on that. All right. So this has an x minus 5, x plus 5. So in that top portion, what do they have in common for denominator? They have x plus 5s in common. So this will equal, well, we have x plus 5, and what's left? And x minus 5, good. So the fraction on the left has them both, so it doesn't need to be multiplied by anything. The fraction on the right needs an x minus 5. You okay with that? So when I combine those out, I'm going to get 2x minus 10 plus 4, so it's 2x minus 6. Does that sound right? So this becomes 2x minus 6 over the... All right. The bottom one, pretty easy again. You wind up with x plus 5, x minus 5. Fraction on the left needs the minus 5, x minus 5. The other one needs the x plus 5. And that just gives me 2x. Keep, flip the bottom. And then go any further. Yeah. What can I take? What can I do? The 2's, not the 2x. I can't cross off the 2x because there's a subtraction symbol, but all the coefficients here are all even. Everything's divisible by 2. So that's the same as 2. See how that's what that looks like, is you can break 2x into 2 times x, and the 2 simplify out. Your final answer is x minus 3 over x. Okay.
You know, once you
All right. So the other thing I want to kind of look at real fast today. I think we'll have a minute to do this.
What?
Where it becomes a little bit easier, once this loads, eventually. Where it becomes a little bit easier is when we start dealing with actually solving. Okay? For example, one of the things that happens now is that we're going to worry about solving these things out. And the idea behind solving them, and I don't think we'll get too far into this. Oops. When we start to get the idea of solving stuff through, why we're going to use all these common denominator stuff is because we want to try to eliminate the fractions. You guys have done that before, okay? You guys have found ways to get rid of having fractions in your problems by multiplying things through by common denominators and so on. Kind of the same thing here. What's the smallest number that both 3 and 4 go into? 12. Okay. So what happens is, if you start to think about it, if I multiply everything by 12, and I'm distributing that 12 to all pieces within there, what happens is this. You have 12 times the x plus 3, or x over 3, excuse me, plus 12 x 4. Long form, that's what's happening. Shortcut wise, what do you multiply 3 by to turn it into 12? What do you multiply 4 by to turn it into 12? So in essence, what you're doing is you're multiplying this by that, and the fraction goes away. And it drops to the super, super fast. That's it is.
So what happened to the
They went away. I multiplied everything by a common denominator. What's 12 divided by 3? It's 12 divided by 4. What's 12 divided by 4? It's 3 times 7. Okay. The idea here is that we're going to get rid of the fractions to make our lives easier. All right. Again, go back to something that looks really, really, really simple. What would you multiply everything by to get rid of that fraction? Oh my gosh. 3. You'd multiply everything here by 3. Okay. So as you write it out, you're trying to get rid of the fraction. And then you distribute to all parts. Okay? Because whenever you have an equation, whatever you do to one side, you've got to do to the other. Right? So that's where you get your 9x plus x is 15. Then you get 3 halves. Notice what I did not use. Decimals.
What?
Decimals.
That's the model.
Okay.
Oh my God.
What's that? Decimals? Yeah, don't use decimals either. They're not good for you.
I should know.
Same idea. Now, let me ask you this. What can't x be? 0. Why?
Because it's undefined.
Yeah, you can't divide by 0.
You can't have 0.
That's what you call an excluded value. Okay? That's an excluded value. So in this case, we know that x can't equal 0. But what would your common denominator be? 2x. So if I multiply everything by 2x, guys, come on. I multiply everything by 2x. This fraction has the x. What does it need? The 2. This one has the 2. What does it need? The negative 11 has the x. What does it need? Okay. You're multiplying by what it needs. Okay. You're multiplying by what it needs. So you wind up with 5x is negative 30. You get negative 6. All right. I hope so. I hope so. The other, guys, enough. It's really annoying. The constant talking, it's really kind of, really annoying. Same idea. Sorry, I didn't get this one cleaned up. I didn't know I was going to get this far today. As you're writing it down, you start looking at it going, all right, what can't x be? 2. Can't be 2, because it makes the denominator 0, all right? So the reason why I'm asking you that stuff is because sometimes you get that answer of 2. That just means it's not possible. Okay? It's an answer, but it's not an answer.
Makes sense.
Okay. And we'll learn more about that at the end, towards the end of this week when we start graphing these things as to what actually occurs when you have zeros that don't work, certain values that don't work on graphs. So here, common denominator is real quick. It's x minus 2. First fraction has it, doesn't need it, so it's just 5x. The 7 needs it. The 10 has it. Okay. So you have negative 2x. You get x equals 2. But what can't x equal? 2. So in this case, this is no solution. What's that?
It's basically like what happened in bought it with resolution and then you came and said, oh, but there is solution.
No, that was for the you're talking about like imaginary stuff? Yeah, it's an answer. You've probably done this before. It's an answer that just doesn't work. Okay? You guys probably have done it with more of a complex equation, but you've done, 7 over x minus 2 equals 4. You got to cross multiply, fraction equal fraction, that kind of stuff. But you knew that x couldn't equal 2. Same basic principle, because we'll get to that little shortcut whenever you do have something like that. For example, when you have fraction equal fraction, whenever it is straightforward fraction equal fraction, nothing else tacked on, no addition, no subtraction, or anything like that, that's when you cross multiply. You guys remember that?
Yeah.
This is a method by which you guys have done before. What's that? Yeah. So what I would do right away is, I see 4 and 16, I can simplify, right?
1/4.
Okay. I was like, well, all right. So I have 1/4, and I just rewrite it. Cross multiply. Is that an okay solution?
Yes.
And it works. And that's what we're trying to do. When you have your cross multiply ones, that's the beauty and fastest.
That's
I don't appreciate being made
Do those. I'll get the, pretty sure the PDF is on there already. PDF is already there. I'll add those problems to it. You also now have, be able to do the 9-5 stuff if you haven't been able to figure that out. I went through that again to make sure you guys were good to go. But give those a shot, shouldn't be so bad.
I know. Sick problem.
Yeah, we should be still done. I'm still thinking we'll probably be done with all of this by the end of the week. At least that's my goal. Should not be such a bad thing. Okay. This is a rather quick unit by doing it in this order. Let's see, today's what, 18?
Yes.
Should be